Welcome, welcome guys to our video lecture on eclipses. Here's where we're going to be going in our notes packets. So if you will, please go ahead and turn to this page. There is no vocab nor bell ringer today. We're going to do some notes, and then towards the end I'm going to leave you with the rest of the class period to review for your exam, which will be on Tuesday. Let's get started. So we're at the very bottom right down here. Eclipses do not occur during each revolution of the moon because the orbit of the moon is tilted. So if you look here at our Earth and our moon, remember there's only one, but we just want to show you the orbital line. It is tilted. So eclipses do not occur during each revolution of the moon because the orbit of the moon is tilted. Remember please that revolution is one body moving around another body. They're orbiting, while a rotation is one body moving around its axis, right? So the spinning of the Earth or moon, spinning of the other planets, while the revolution is one body moving around another body. Say the moon revolving around the Earth or the Earth revolving around the sun. We're going to start over on the left side of your page with solar eclipses. So solar eclipses occur when the moon blocks the sunlight, casting a shadow on the Earth. So if you will, draw in right there that moon shadow onto the Earth. So you can see a solar eclipse from many different places on Earth, but you will only see that total darkness or that complete eclipse right where that shadow is over. So right here it would be in this part of Africa. So anything occurring around this region right here. So if we were up here in North Carolina, or not Africa, South America, if we were up here in North Carolina, we could still see the eclipse, but we wouldn't have a total eclipse. It would not be total darkness. Okay. Again, a total solar eclipse occurs when the moon completely blocks the sun. So if you can see, there's the moon right there. The sun's behind it. The moon is completely blocking the sun. We would see complete darkness in parts of the Earth. A partial solar eclipse occurs when the moon blocks only a portion of the sun. You can see the moon right here blocking only just a little portion of that sunshine. We are missing a little bit of notes right here, and it's these occur during a new moon. So only a new moon will this happen. Let's look at some pictures right here. So these are examples of eclipses, which is a total solar eclipse, this picture right here on your left or the picture on the right. The picture on the left is a total solar eclipse, while the picture on the right is only a partial. Remember, a partial solar eclipse occurs when the moon only blocks a portion of the sun. Portion, partial, total, completely. Okay, let's talk about, now we're going to switch pages, switch our thinking just a little bit to a lunar eclipse. Lunar eclipses occur when the Earth blocks the sunlight, casting a shadow on the moon. Okay, remember this distance is not to scale. The Earth is not that close to the sun, and the Earth is also not that big compared to the sun. An important thing to remember when we're looking at this diagram right here is that for a lunar eclipse, our order of celestial bodies is Sun, Earth, and then Moon. While with our solar eclipse, it is Sun, Moon, and then Earth. So for a solar eclipse, the Moon is in between the Earth and the Sun. While a lunar eclipse, the Earth is in between the Moon and the Sun. Okay. So again, a lunar eclipse is when the Earth's shadow blocks the sunlight from onto the moon, meaning we cannot see part of the moon. There are some special shadow labels right here. So the umbra is the moon shadow on the Earth, and the para-umbra is the Earth shadow on the moon. This umbra right here is just a more darkened region of the shadow. Lunar eclipses can only occur during a full moon. The moon has got to be full for this to happen. And then here again we have that umbra, or that direct shadow of the moon. Only when the moon is completely in the umbra do we see this red moon. Due to the scattering, this red is caused by the scattering of the sunlight through the Earth's atmosphere. So as the moon passes through Earth's shadow, it appears red due to the scattering of sunlight through the Earth's atmosphere. When the moon is only within the penumbra, we see just a little bit of the moon being shaded, and it is not red. Only when it is in the umbra is it red. These aren't super important terms for you to know, but just know that when it is in the most direct of the Earth's shadow, we see a red tint to the moon during a lunar eclipse. Okay, that is it for you all today. I hope you enjoyed this lecture on eclipses. I hope it helps you kind of remember the different types of celestial phenomena or happenings or events. So remember that a solar eclipse, the moon is in between the Earth and the sun. It is the moon's shadow that blocks the sun from the Earth. It can be both partial and complete. And then with our lunar eclipses, remember that the Earth is in between the moon and the sun. And that the moon will not completely disappear, but will look a shade of red. Okay, I hope you enjoyed. Have a great day. Spend the rest of your time, please, reviewing for your exam that you have. We'll have another review day on Monday. Your exam is on Tuesday. Be ready to take that. Make sure you have all your notes done because you can use your notebook again, so it'll be helpful if you have your notes done. Get working on your stuff, review, spend a little bit of time maybe reading over your notes, going over concepts, maybe rewatching lecture videos if you need it for a particularly hard concept. Whatever it takes to help you be successful in this class. Have a great day, guys, and remember that you are responsible for your grades. So are you putting in the effort? Are you putting in the work to be successful in this class? If not, you need to reevaluate and start working. Have a great day.